फिर नहीं गए थे, चलो। फिर- फिर- हाँ, तुझे स्पीच नहीं गए। हेलो जनिल। हेलो। तेरा लाइफ स्ट्रीम पे आवाज नहीं आ रहा।
और
मेरे साउंड भी सही है।
म्यूट था
ना।
भाई। डन। ओके वेट, तो क्या करूँ?
अभी
ए से चालू
सर्टिन
करूँ
लगाएगा।
वापस?
हाँ शॉर्ट में बता कुछ।
ठीक है भाई, ये चालू कर देता हूँ। ओके, सॉरी फॉर द स्ट्रीम, आई एडिट इट आउट। वेलकम टू द live stream A to E Ryan programming contest. Let's start question by question. Question A: you're given a riddle where you have A and B given. You need to find the smallest m, so that the remainder when you do m mod A and you do m mod B, both are same. Now, main approach for this is, let's say I have an A, B. This is my number line. Okay, we have 0 here. So now my m can be starting from A to any number ahead. Okay. Now let's just try to see where m can be. Can m be equal to A? If m equals A, m mod A equals 0, m mod B equals m. Since the thing is like B is greater, so always whatever you modulo, m is gonna be there. So this fails. Let's do the same thing for, wait, let's do the same thing for m, A, and B. Basically, m lies between A and B. What will happen is m mod A is less than A and m mod B equals m. The same thing is happening. Since m is less than A, this will just fail. So I know this entire range m can't be there. So now to find the first number over here, the best thing like the best thing you can do is m mod A equals m mod B. The best thing is both of them turn out to be 0, and this happens when m equals LCM. So that's the code. You take the LCM, you take the input, you print the LCM. That's it. Let's move on to B. Yeah. So yeah. In B, you're given a string. Like the main thing is you don't want m consecutive zeros, and in one operation you take a k size window and make all the elements in that one. Like you make everyone a strength. Okay. Now the first approach, initial approach, which like even I had, most of you might have had, is wherever I get a size m window, let's say m is 2 and k is also 2. Let's just I take this window and I make it 1. Okay. But this is not always optimal, because let's take this as an example. Okay. This window is 2 and this window is 2. Technically, with that, I'll require one operation here and one operation here, total 2 operations. But what I can do is I can take k over here. So this becomes 0, 1, 1, 0, and there are no two consecutive zeros. And here I required only one operation. So the main intuition and the main observation over here is, let's say I have m consecutive zeros. Okay, all of them are zeros. if I make this one, all these zeros don't really matter. No, they don't affect me. So if I make this one, I'll make the entire future, whatever k is, I'll make all of them one. Because this is the most optimal because I am like leaving out the maximum zeros as possible. So that is the entire algorithm. Like if I find an m size window, from the first index, I go to the kth index, m plus kth index. This is m plus k. And I make everyone one here. Or I just disregard them. Doesn't really matter. Does this make sense? Yes, no. Good. So now let's move on to the code. Pretty simple. Like you have your answer, which is the number of operations required. I'll just zoom in. Wait. Yeah. Current window may how like current basically says in the current window current how many current consecutive one or zeros are there, and the previous is the previous value. It's either one or a zero. So now if the current index is equal to previous, I increase my current window size, or else my current becomes 1 and my previous becomes the current value. Now, the only other case is when my current is equal to m, current window, and my previous or my current window is m and my previous is 0. Basically, m consecutive zeros. Then I need to do one operation. I do 1 plus plus. Now, for j from I to I plus k, I iterate and I make everyone 1, or I just disregard them. I don't consider them. And so, yeah, what happens is, let's just take an example like this. M equals 2, K equals 3. So now at this index, my cur equals M and M previous equals 0. So this is my index where the flag happens. So what I do is I need to make this entire thing 1, 1, 1. So what will happen is my previous, like I just jump to this index, my previous being 1 and my current size being 1. So what, like I jump to like this. Since my this loop is doing I plus plus, I go j minus 1 because I'm going to jump. And this is going to be 1. Actually, yeah. Oh, damn. Is my failure accepted? But it's just 1 and oh yeah, my current is 0. That is why this previous doesn't make sense because my current is 0. Like if it's going to be same, I'll increment 1, or if it's different, I'll also keep it 1. So yeah, just that's why I made it 0. This doesn't really matter. So does this make sense? Like basically, I jump to the I plus kth index with my curve being 0. No, I jump to here, like I plus k minus 1 thing. And then the next one is here. So that is it, and I move on. And at the end, I print out answer. Any doubts here? No. Then cool. Let's oh done. Let's go to C. And yeah, Rishi Kumar. Look, okay, D before C. Yeah, makes sense. Can do D before C. But like, yeah, let's just do D before C as we suggested. D is actually easier to implement and understand. So, yeah. Now, D, you're given n stones consisting of base 0, 1, 2. Okay, with pieces stacked on like basically. Let's just clear this. Basically, you have an array with 0, 1, 2. Okay, that is the meaning of this entire thing. Now, in each move, you can choose any two indices, and if the difference between them is 1, what I can do is from the column with more inscriptions, I can transfer it to the lesser one. And it is guaranteed at least one column contains exactly one inscription. Since beauty is the main, like, yeah, they want ascending order. So whatever this array is, I want to make it in terms of some zeros, then all ones, then all twos. Like this is my entire array. This is what I want to make. Now, how do I do that? Now, let's just see what this does. Okay. What are the possible differences of 1, 0, comma 1 and 1, comma 2? That is the only thing. What happens to 0, comma 1? It becomes 1, comma 0. And what happens to 1, comma 2? It becomes 2, comma 1. Okay. So this is what we use. Now, let's just see now, if I want to put 0 here, since it's 0, cool, let's go. Now here I got a 1. Let's say there are some zeros over here also. I'll choose the last 0 over here because I don't know no, what is the window in which the zeros lie. So whatever the last 0 is, I know for sure it is wrong. So I swap these two values. And what is happening is I'm basically swapping 1, 2 becomes 2, 1, 0, 1 becomes 1, 0. So the last 0 and the first one, I just directly swap them. Since I swap them, this becomes 0 and this becomes 1. Okay, same thing. Now if I encounter a 2 and I want a 0 here, what can I do? To make a 2 to a 0, I'll need to make 2 to a 1 and then that 1 to a 0. Same thing, the last one I get, I swap it with 2, the last one. And I swap that. So basically what happens is, let's say 0, 1, 2, 1, 0. No, right, 0. So firstly, I swap these two values. This becomes 0, 2, 1, 0, 1. And now I'm going to swap this out. So I'll swap the last one with the first two. So what happens is I get this. And now same thing. Once again, I'm at a 1. So I swap these two values. 0, 0, 0, 1, 1, 1, 2. And yeah, then I move on to 1. And now the thing is, once I fixed zeros, okay, for all the ones, I only have twos to swap with, no? So I'll directly swap with the twos. If I have a 2, I swap it to the last one. Okay. But now the thing is, how do I maintain this? How do I get the last one? How do I know what is the current index? That is where we use a set or a priority queue, whatever. So for that, I'll explain with code so that it's just easier for you. D. Okay. So now what I do is, for every index, I take the array input and I put all the indices in 0, 1, 2 ka sets. Okay. Now just leave this change function out. Now what do I want to do? Like this entire algorithm for all zeros, for all places. Wait, let's just expand. for all places where I want 0. If 0, continue. If 1, swap with last 0. If 2, swap with last 1, and then swap with last 0. Cool. This is the entire algorithm in words. Correct. Let's just write that words in code. So for all the zeros, basically zeros ka size, I have to add all the zeros. Now, if my current index has 0, continue. If it is 1, I swap 1 with 0, or else I swap 2 with 1, then I swap 1 with 0. That's it. And for the all the remaining ones, if 1, continue, or else I swap 2 with 1. Like basically that's it. Now, how do I swap? How do I change? That is my change function. Last value is basically the sets are begin. Basically, in a set, you have sorted indices. So I1 less than I2 less than I3. R begin just points to this value. So the pointer to the value at the R begin will be my index. Now, since I'm swapping, I'm removing like the first value and first set and the second set. It's just generalized. So in the first set, I'm no longer having the index I, so I'm erasing. In the second set, I'm no longer having index end, I'm erasing it. I'm manually swapping and I'm inserting the values. And I'm pushing by this operation. I'm swapping I plus 1 and index plus 1. That's it. So this is the entire code. And finally, I just print this operation out. Any doubts here? Hello.
No doubt.
What? In queue. Okay. I submit this earlier. Cool. Now coming on to trapped in witch's labyrinth, which is C. This is, let's make a grid. So this is an arbitrary grid. What you're given is, you're given a grid with values U, D, L, R, and question mark. So just self-explanatory. You go up. Left means you go left. Right means you go right, and down means you go down. So in this grid, instead of ULDR, I'll just represent with arrows so that it's just easier to visualize. And a question mark can be anything. Okay. I need to set it later on, but let's just keep it as question. Okay. So now let's just see the base case. Okay. The thing is, whenever like the entire thing is, if I'm at an index, I'll just follow what that Celka instruction says me. If it was a left, I'll move on here. If it was here, and if I'm at this index, I'll move out of this grid. This is basically a prison, and I don't want the person to move out of this grid. So at this value, at this position, if it's either this or this, I'm just going out. Okay. So that is it. Hmm. Now, how do I like what is the entire thing? Let's just say it is this. Okay. Left, right. Wait, take this example. Hmm. This is basically a 3 by 3 grid, and here you have up arrow, up arrow, up arrow, left arrow, right arrow. question mark, bound, bound, bound. Now, what we see is, firstly, let's just check for the borders, okay? Because borders will be the one going out of the entire grid. So this goes out, this goes out, this goes, all of these goes out, okay? Now from this question mark, I can go to four different directions. Since all of them are going out, basically all of them are going out, I won't have any index which gets trapped. Trapped in the sense, if it is something like this, or if it's something like this. These are the cases where it gets trapped. Basically, infinite loop, you just stay there. And yeah, so that is why in this question, like it is 0 over here, because whatever I do assign this question mark, I'm just going out of bounds, like I'm just escaping the matrix. Now over here, huh, let's just do it for this, okay? So good. Now what you can see is I can just make one left, like right, left. Now all these question marks just point towards this. So this goes up, this goes up, this goes up. Basically what I mean by is, if I have two question marks, I want all the other question marks, like all the other adjacent neighbors, to reach this set basically of traps. So all these question marks will in turn get trapped. I can make this also a trap, but it's just easier if I just make this as a trap and all of them point towards this. Okay, and let's just see this for this test case. Yeah. Over here, you see this goes out, this goes in, this goes in. Now, if since I have a question mark, I can place it like this, and this entire thing is sorted. Like this gets trapped. Since this entire gets trapped, this question mark points towards down, this question mark points towards down. Same thing, this goes right, this goes down, this goes left, this goes down. So all of these escape, this escapes. So there are four values of escaping, and the other five are getting trapped. Now, like the main algorithm, like what I'm doing for this is, for each index, I'll just do a DFS. Okay, for each index, I'll do a DFS. If I'm going out, that means I'm not getting trapped. So I also have a trapped matrix, trapped or not. It just says that if this index is trapped or not. Now, since these three are going out, all of these will become 0. Now left, since I'm doing a DFS and this is already visited, if this was trapped, it will be trapped. If this was not trapped, then this value will be 0. So I just transfer this value to here, which is 0. And since this is going right, it's just 0. Okay. Now, what happens on a question mark? That is the only case. In a question mark, I go all four directions. If any of those four directions leads to a trap, I set it to that direction. That's it. That's the entire logic for the code. Now, how do I implement this? Is my code. Does it make sense? Like this DFS logic? Hello.
Yes, yes.
Yes. So now let's move on to. Oh wait, huh? Let's move on to the code. See. So first I initialize the grid, which is a vector of string. I have a trapped array and a visited array. I've kept it separate because it's just, I think it's needed, but yeah, it's not needed. I can set it as -1, but it's for me to visualize trapped and visited. I just kept it separate. Now this moves is basically if I have a U, what happens to the I and J? D, what happens to IJ? L, what happens to IJ? And R, what happens to IJ? And this direction is basically to move to all four directions. I'll move on to this code later. So now for huh, okay. Now for every index, what I do is just do this DFS. It was not visited. It's like a it's like you're doing DFS or if you're figuring out number of components in a graph, it's the same code. Yeah, and yeah, you just do the DFS, and after that, just for get the answer if it was trapped or not. You just increment. Okay. Now the main code for DFS. These are the base cases. Now if it was like if you're at a disk index, I make this as visited. Now if it was question mark, this entire thing I'll explain by this way. So what my moves array is -1 0 1 0 -1. Okay. If I take these two together, what is happening? This is basically saying you go up, correct? Because if you're at an I comma j, I -1 comma j is just above it. So this is basically up. What is these two? 0 comma 1 means I'm incrementing j, I'm going to left, I'm going to right. What is 1 0? It is left, and 0 1 is down, down. So that is what my direction array is. And I just iterate till 4. And since I'm taking this 2 ka size, I becomes direction plus k, direction of I plus direction of k. J becomes j plus direction of k plus 1. Okay. And this is basically lambda function. If any of them return true, I set flag to 1. And if whatever the flag is, I set my trapped value to that. Okay. And if it is not question mark, I get that pair and I do that move. Whatever that move returns me will be my trapped value. Now, how am I checking if it is true or false? If it is going out of bounds, it is false. If it is already visited, then whatever the trapped value it has, I just pass it on. That's it. Any questions over here? Let's go. AC.
No questions.
वो हो गया पहला हर्डल क्लियर भाई
AC तो हो गया भाई.
हो गया भाई एफएसटी का क्लियर हुआ
Yes. Now, only thing is if I reach CM or not. So why am I excited? Because with the caret delta, I am most likely reaching CM with this contest, and this is my first contest of reaching CM. So hoping, and in my college I'll be the third, and after a long time be CM. So it's a big thing. Now let's move on to E, which is permutations harmony. Now the question is very long, but all it says is let's say I have a permutation P1, which is basically let's say P0 uh, P1, which is P1 of 0, comma P1 of 1, comma P1 of 2, so on P1 to P1 of n. Okay, this is my first permutation. I'll have similar permutations for P2, so on to Pn. pk. Okay. Now the question states a set of permutation is k harmonic if, like, it is written in a different manner, but all it boils down to is these sums basically, um, summation p of I comma 0 equals summation p of I comma 1 and so on, comma n. Okay. This is what a k harmonic permutation set means. Okay. So now how do I get this equals up? Let's just try out some examples. Okay. 1, 2, 3, 4. How can I make this, like, just adding one more? How can I make this uh, same sum? I just reverse it. What happens is, like, reverse it. What happens is the summation just becomes 5, 5, 5, 5. Okay. So if I'm reversing, this just makes sense. Okay. Let's just try for another case. 3, 4, 5, 6. Even. Okay. Currently. This is how I solve this question. So in the future, if a similar question comes, this is what my thought process is, so that you can just replicate it. So, yeah. So if I just reverse it, if I take just normal increment increasing array, if n is even, wait, so basically, wait, if n is even and k is 2, I can just do this, right? Let's just test for odd. 1, 2, 3, 3, 2, 1. This is also giving the same summation. So I can just make, if k equals 2, I can just do increasing, then decreasing, and I'll get my sum equals this. Does it make sense? Yes, no?
Yes.
Yeah. Now, the thing about this is, let's take a different permutation of this size only. Okay. Let's take 4, 1, 3, 2. Okay. Since I want to make 5 as a sum, what will happen? Wherever 4 is, I place 1. Wherever 1 is, I place 4. Basically, I'm doing b of I equals a of I. 5 minus a of I. And this 5 is basically 1 plus n. Okay, since that is the value I want to reach. So this becomes 2, this becomes 3. And this is also valid. Correct. So what I can see is k equal to 2 now. If k mod 2 equals 0, I can just keep on taking permutations and their complements. Does this make sense? Because I just take set of 2's, right? I can take this, then I take this. Now, only edge case is if k greater than the permutation, like basically k greater than permutations, or yeah, just k greater than permutation. What happens is, then I print a no, then it is no. Okay. So I just keep doing this permutations thingy. If my and I just keep on adding to my answer vector. Okay. If my k is greater than answer dot size, I print no, or else print yes, print answer. Okay. This is for k is even. Okay. Now, mm, oh, that was my edge case. That is where I was getting double. Ouch. Stupid. But now I know why I got a W here. I'll explain it later. But now, now let's come to odd. Okay. Let's do k, k is odd. Okay. Let's try in the question itself, in the test cases itself. You see, at 3 it is working out. Okay. So let's just make 1, 2, 3. I want to have some two permutations such that the sum is equal, right? Now, how do I do this? Like, I did this by just observing, like, just brute force, like, for this case, I just brute force the values. Actually, what I did for 5 values, and then I generalized it. Okay. One thing I noticed is, if I add 5 with the middle term, which is 8, okay, then what I can do is, for this thingy, I can make it as a 4, 5, 6, 7, 8. Huh. 4 to 8 permutation, like all values between 4 to 8. If I have all values between 4 to 8, I can choose another array, no? Basically, I can choose another permutation, and the complement will be just like, yeah, I'll explain this part later. But yeah, let's just, my main aim was take 2 permutations, I keep this as fixed, such that I get a continuous sequence of numbers. Why is that? Because let's say I have 4, 5, 6, 7, 8. I can do 5, 4, 3, 2, 1 here. And this just turns out to be 99999. Okay. So I just need to make this 4, 5, 6, 7, 8 with 2 permutations. Now I just observed after this. Okay, I just manually was doing. Now I want to make a 7. Okay, I've used a 4 here. I've used a 5 here. How else can I make a 7? I have to put a 3 here. I have no other option. Okay, so I have 7 here. And now, how do I make a 6? Either I can put a 1 here or I can put a 4 here, right? Putting a 4 here is just beneficial. So I put a 4 here. And now to make a 5, yeah, 5 I put a, no wait, huh, 5 I make with this. No, wait, what? I make a 7 here. I make a 6 with a 1 here. Basically, yeah, huh, that is what I'm doing. So, let's just copy this. Huh. So I need a 7 here and let's make a 6 here. So what are the values needed for this? This is basically 5, this is basically 3, this is basically 1. Now to make a 5, I can make it with, like, I don't have a 3 here, so I'll have to make a 4, put a 4 here and a 2 here. So this becomes 5 and 4. So now you see 4, 5, 6, 7, 8. Now to make a complement, what do I do? I just do 4 plus 8. So what is 4 plus 8? What is 4 plus 8 equals 12. So now here I'll put, what is this? No, no, no. Yeah. So over here, I'm not doing 4 plus 8. I'll do 1 plus 8. Why is that? Because now I have 1 to 5 ka permutation, not 4 to 8 ka permutation. So now this is just 9. And since this is 9, this array becomes 9 minus 5 is 4, 9 minus 4 is 5, 9 minus 8 is 1, 9 minus 7 is 2, this is 3. Do you see something special over here? This array. It's just you start from n by 2 and you go to cyclic order. Is this true? Correct. So if I fix this as A, this as B, I can get this by doing the same thing. Take the sum and get this array. Does this make sense? Hello.
Yeah.
Yeah. So that is it. Now this is for n is odd. You can try out some more examples. I did try it for 3, I did try it for 5, and try it for 7, and it was just working. So you can just generalize it, because like you can always have this 3 card thing. Now the only thing is, let's try for a 4. Okay, 1, 2, 3, 4. Let's try doing the same thing. Let's take a midpoint. Let's take this as a midpoint. So what I'll do is I'll put a 6 over here. I'm just basically making a 4 here. I'm adding a 4 here. Now if I'm adding a 4 here, now I need to make a 5. To make a 5, either I'll put a 1 here or a 2 here. Let's put a 2. Let's try both. Okay, this becomes 5. To make a 4, I'll require a 3 over here. And now what? I can't add another term here. So the remaining is what? 1. And I'll be left with a repeating 5. Okay. Now same thing, let's do a different choice. Let's put a 1 here so that we have a 5 here. Now to make a 4, I don't have a 1, so I'll have to put a 2 here. I'll have to put a 3 here, and I'll have to put a 2 here. It just turns out to be the same thing. 4655. And the issue with this 4655 is, since I don't have this, all of them will vary with a sum of 1, right? Now these two values, like these two values or these two values, will end up being the same by taking any other permutation. So I can just refute this, that in size 3 this won't work, and since in size 3 it won't work, size 5 also it won't work, size 6 also it won't work, because what is happening is, let's just take an example. Okay, let's just do the smart thing. Maximum ko I'll give a 1, minimum ko I'll give a 4, and the other two will have 3. My sum turns out to be 8, 7, 7, 8. You're still stuck with these two numbers together. Anything you do, you'll be stuck with these two numbers together, and the other numbers doesn't really matter. Like you won't have all the numbers equal. So you just refute this, that if n is odd and n is even and k is odd, You just break. You print no. So that is it. Those are the cases. If k is odd, you just print this. If then n is odd, you first get the thing is now you get this ABC. Now you'll do the permutation thing, okay? Oh, actually hashing is also not required. Wow. It's just smart, okay. I just prefer hashing, okay. Now I just now in this logic, what I was doing is I am generating all permutations till no match. Same thing I'll do here, all permutations till no match. And what is this match thingy? I can just hash this entire permutation and check it in a hash map. So that is what I'm doing. Now this is my hashing template. This is my complement, and this is the check function which I'm doing with it. Actually, this is just not required. It will pass either. I just hallucinated now. Okay. So now what I'm doing is I took the input. I have a map for storing the hash values, and I have an answer. Okay. If k is
Jenil check.
even, hmm, updated. Let's
Yes.
go. 172.
भाई और by a margin भाई.
Damn.
Congratulations, Jenil. Let's go.
Yo,
I
congrats.
Viram भाई को
Crazy.
Viram AFK भाई. Congratulations भाई.
Thank
Crazy.
you. Thank
हार्दिक को
you.
भी congratulations भाई.
Yeah, so I'll just explain this
हार्दिक की
code
14
and
और
just
6.
move on. Yeah. So now I initialize the first permutation, which is A. Now this is basically standard next permutation code, and I iterate till my answer size is less than k. Either my next permutation will end or my answer will end. Now here I initialize B. B is just the complement, and complement I calculate here. I calculated over here. It is just 1 plus n. That is just the complement. Wait, what is it? Over here, yeah. This is it. So this is my value and this is my A. So my complement just takes the value, takes the A, and just gets the complement of it directly. Okay. This is my complement and returns the vector. Now you have the vector. Now I just check if it exists, A has existed earlier or B has existed earlier. Just continue. And this existing code is basically I hash it. I check if the hash is already existing. If it is, if it is yes, then I return true, or else I put it in the hash. That's it. And then I push back to the answer till it's just there. Now I do this. And an additional check because I was just paranoid, but I just don't need this. This check function basically does this actual check that my sum is equal, but I've it constructed such that the sum will always be equal. But I was just paranoid. I just wasted 15 minutes because of one case. And this check function actually helped me with that. I'll come on to this. I'll move on to this. And now if n is even, you print no. If n is odd, now this is the base case, which I should have just written it over here. Controller, Control V. This would have saved me from a WA because what is happening is if k is even and n is 1, I was just making 1 comma 1 like 1 and 1, which is just wrong. So that was my issue. Yeah. And then now here what I'm doing is I'm making the A. My B is what I'm constructing from n by 2 to n, and 0 to n by 2 I'm just putting the values of j. I get the sum, and C is just complement of this value. Now what is this? Here I did 1 plus n minus a of I, okay? So now let's just see over here what is happening. I am taking 1 plus 8, and what is 8? 8 is 5 plus 3, right? So that is it. This is 8 and this is 1. And since n by 2 is just floor, I am doing plus 2. The same thing. Now complement. Now first I check if it exists. I doubt this all ever happens, but I'm doing this because in my existing code I'm adding it to the map. So yeah, I'm checking. I'm pushing back to my answer. And now since I've already done, I do while first. Here I was doing do while. Here I do while first. And the same conditions, I generate a B, I check, and I just do that. I check my final answer and I print. That's it. Any doubts? No. And probably see you stream. Bye bye. Hope you liked the contest. Hope you liked the PCD. Join Discord for the bot commands. Very fun. Done by Viram and Mar. Cookum. Good stuff. Like the bot is very fun. And yeah.